This is the screencast for section 10.3, example 1, polar functions in calculus. Okay, so first let's do a little bit of review of polar functions, then we'll get into the calculus part. Remember, polar functions are a different way of expressing rectangular coordinates. Rectangular coordinates are your typical x comma y, so 2 comma 2 would be right 2 up 2. Polar coordinates are expressed as a rotation of an axis around the origin and then a distance from the origin. So the point in polar, 2 square root 2 comma pi over 4 is a rotation of pi over 4 that is 2 square root 2 units away from the origin. And then also remember that if you have a negative rotation, the rotation will travel clockwise, and then a negative distance will travel the opposite direction of that ray that was rotated. So for example, the point 2 square root 2 comma pi over 4 can be expressed as negative 2 square root 2 comma negative 3 pi over 4. So here that is negative 3 pi over 4, negative 2 square root 2. Negative 2 square root 2 comma 5 pi over 4. So we could have gone 5 pi over 4 this way, ended up with that same ray, and then gone negative 2 square root 2, so backwards again. Or just 2 square root 2 comma 9 pi over 4, so a full rotation and a little bit 2 square root 2. There's infinitely many ways to express a polar point. This next example is going to ask you to do too. So example 1, rectangular and polar coordinates. First we're going to find the rectangular coordinates for the points with the given polar coordinates. That's part A. Then in part B we're going to find two different sets of polar coordinates for the points with given rectangular coordinates. So in A we're going from rectangular to polar, and B we're going polar to rectangular. Alright, so little I, little 1, whatever that is. 4 comma pi over 2. So I'm looking at a rotation of pi over 2, which is straight up the positive y-axis and 4 units away from the origin. The point at the end of that would be 0 comma 4. Number 2, negative 3 comma pi. So that's a rotation of pi, but we're going negative 3, so it's going to go backwards the opposite direction. So that point is going to be 3 comma 0. Now number 3 isn't so simple. It's not straight on an axis like 1 and 2 were. Number 3 is 16 comma 5 pi over 6. So I have to rotate 5 pi over 6, not quite half a circle, and then go 16 units away from the origin. So that's right here. Now we can't just say, oh, that's 0 comma 16 or negative whatever comma 16, because it's not. 16 is the hypotenuse. We do know a reference angle here, so I can use some trig to help me find the x and the y coordinate to help me with the rectangular coordinates. So I'm going to set up that x is going to be 16 times the cosine of 5 pi over 6, and then that gets me negative 8 square root 3. Then y is going to be 16 times the sine of 5 pi over 6, so opposite over hypotenuse for the y, and then adjacent over hypotenuse for the x, and then solve for x, or solve for y respectively. So then that would make the y coordinate 8. So in total, the polar coordinate, or the rectangular coordinates, are negative 8 comma, or negative 8 square root 3 comma 8 for the polar coordinate 16 comma 5 pi over 6. 4 is about the same thing. We have a negative pi over 4 rotation, so that's going to rotate clockwise pi over 4. But then the r value is also negative square root 2, so that's going to go backwards. So I'm going to end up in quadrant 2, and I need to find the x and y coordinate by again saying x equals the square root 2 cosine 5 pi over 4, or negative 1. And then y equals square root 2 sine of 5 pi over 4, which would then be positive 1. So the rectangular coordinates would be negative 1 comma 1 for the polar coordinate negative square root 2 negative pi over 4. Part B, find two different sets of polar coordinates for the points with the given rectangular coordinates. So the rectangular coordinates in this case, 1 comma 0. Well, there's infinitely many ways to express that because of coterminal angles and having a negative r value. So two easy ways I think would be the polar coordinates 1, 0, so 1 unit away from the origin as a rotation of 0. Or how about -1, pi, so a rotation of pi, but then going the opposite direction, 1, which would still give us the same rectangular coordinates 1, 0. Part 2, -3, 3. Well, -3, 3 is in quadrant 2. The rotation is unclear. How far away it is from the origin is unclear. So we're going to do a couple things. We're going to set up a reference triangle, and then we're going to say that theta, which we don't know, is going to be the inverse tangent of -3 over -3. So the tangent, the rotation, is opposite over adjacent, so -3 over -3, which means that rotation is going to be 5 pi over 4. Now remember, pi over 4 might work here, but it has to land in quadrant 2, so that's going to be 5 pi over 4. Now, how about that distance away? Well, that's a little Pythagorean theorem. So r squared is -3 squared plus, and that should have been -3 squared, so 3 square root 2. So the polar coordinates are 3 square root 2, 5 pi over 4, and then another way that you might express that might be 13 pi over 4, so a full rotation and 5 pi over 4, and then the distance 3 square root 2. Part 3, 0, -4, so that one is straight down the negative y-axis. That one's pretty simple rotation-wise. I don't have to do any calculations. That's just a rotation of 3 pi over 2 and 4 units away. Or I could call that a rotation of -pi over 2 and still 4 units away. Part 4, 1, square root 3. Well, 1 square root 3 is going to be in quadrant 1. Again, I'll set up a reference triangle, which I didn't draw, but theta is going to be the inverse tangent, so opposite over adjacent, square root 3 over 1. The inverse tangent of square root 3 is pi over 3. Now the distance away is also going to be found by Pythagorean theorem, so r squared equals 1 squared plus square root 3 squared, which is square root 4 or 2. So that's a distance of 2 away from the origin, which means the polar coordinates I found are 2, pi over 3. Another way of expressing that might be -2 and -2 pi over 3. So if I rotated -2 pi over 3 and went at opposite direction 2, I'd still get that point in rectangular coordinates 1, square root 3. The now try problems are actually 1 and 3. So in problem 1, we're going to plot each point with a given polar coordinates and find the rectangular, and then in 3 we're going to do vice versa. So in number 1, we have a rotation of pi over 4 and a distance of square root 2. So I'm going to set x equals square root 2 cosine of pi over 4. So I'm going to find that x coordinate by using trig cosine. And I got 1. And then the y coordinate is going to be using sine, the vertical coordinate there, and also equaling 1. So the rectangular coordinates are 1, 1. Part B, 1, 0. Well, that point is right on the x-axis. So 1, 0 are the rectangular coordinates. Part C, 0, pi over 2. So that's a rotation of pi over 2, but 0 away from the origin. So it actually doesn't even matter the rotation on that one. If it's 0 away from the origin, 0, 0 are the rectangular coordinates. Part D, negative square root 2 and then pi over 4. So rotation of pi over 4 and then square root 2, but in the opposite direction. So we're going to look at quadrant 3. And then if I set x equal to square root 2 cosine of 5 pi over 4, so I use the forward rotation, the counterclockwise rotation value, I got -1. And then y equals square root 2 sine of 5 pi over 4, which is also -1. And that gives me the rectangular coordinates -1, -1. The other now try problem number 3. We are given rectangular coordinates, we got to find polar. So number 3, -1, or +1. If I take the inverse tangent of 1 over -1, I get the rotation of 3 pi over 4. And then Pythagorean theorem will tell me that my distance is in fact square root 2. So square root 2, 3 pi over 4 is one way of expressing that. Or I could do the opposite rotation, so negative pi over 4, but then go negative square root 2, also to the rectangular point -1, 1. Part B, 1 negative square root 3. If I take the inverse tangent of negative square root 3 over 1, I get a rotation of negative pi over 3 to get me into that quadrant 4 where I need it. And then Pythagorean theorem tells me that r equals 2. So 2 negative pi over 3 is one way of expressing that. Negative 2 comma 2 pi over 3 would be another way. So negative pi over 3 or 2 pi over 3 and going backwards. Part C, 0 comma 3, that's a rotation of 0, a distance of 3, so the polar coordinates are 3 comma 0. Interesting. Another way of expressing that could be 2 pi is the rotation with 3 units away from the origin. Part D, negative 1 comma 0, that could be any rotation, a rotation of 0 if you want, and then 1 away from the origin backwards. Or we could say that that's a rotation of pi and then a positive 1 still going along that ray to get me to negative 1 comma 0 in rectangular coordinates. Now I should also be writing p next to all the polar coordinates. That's how we differentiate between polar and rectangulars, is you'll see the p next to polar coordinates, but then nothing next to the rectangulars.